So review from yesterday. I'm actually going to jump to page 9 for a second. Okay, on page 9, just a review, we have a table here. It says year and total average leisure time per day. We call the year would be called the independent variable. So review some terminology. We call the dependent variable would be associated with the y. So it's always x comma x is first in a column. Second is always your y. And y always depends on x. So the dependent variable would be the total average leisure time per day. Domain are the elements of the first set, and range is the elements of the second set. Okay? We also talked about relations and functions. What's a relation? Think relate. Yeah? Yeah, we're relating two sets together. Relate one set, how does it relate to the second set? How are two things related? How are year and total average time related? Okay, that's a relation. This is a relation because we're putting a correlation between year and average leisure time. What is a function? A special type of relation. That's first part.
Associated with only one element in the range. It's a fun relation.
Okay, so each x has only one y. Each input has only one output. Okay, so each x has only one y. It's a special type of relation. Okay, so going to this example here that we left off on yesterday, let's write it as a set of ordered pairs that we have here. So for writing the whole set, we use set brackets. Little squiggly lines. Remember, you can do this symbol if you really are weak with that. Okay, give me one ordered pair. 10 and 50. We're on page 8. Oops, okay, try that again. 10 and 50 with another ordered pair. 20 and 100. So each ordered pair, it's always x comma y when we have ordered pairs. And we put a comma in between each ordered pair. So 10 comma 50, 20 comma to 100. Then we have 150 and 4200. And then last, when we're done with our ordered pairs, we have to close the set. Close the set. Oops. Close the set. Okay. Let's go down to the last question, and we'll go back to the middle question. So the last question is state the domain and range. Okay, so what would my domain be? It's a special set. So, yeah, Alex. Yeah, the 10, comma, 20, comma, 30, comma, 40. We wrap that in its own set brackets. Okay, what is the range, James? Yeah. Comma. 100. 150 and 200. Okay. Now, the $1,000,000 question. Is this a function? Why or why not? If you think it's a function, put your hand up. If you think it's not a function, put your hand up. If you have absolutely no idea, put your hand up. Okay, so why or why not is this a function? The answer is yes. No, that's not because it goes up by 50. Paul? Every x has only one y. Or we can expand that. What's the x in this problem? The number of tickets. So every number of ticket, each has only one cost. Each group of number of tickets has only one cost. So if I'm buying 10 tickets, it's not going to output 2 different costs. So each number of tickets has only one cost. One cost. Each x has only one y. That says cost here, sorry. Okay, So what I'd like you to do is try the next question on your own on the next page. Okay, so write the ordered pairs, write the domain and range, and then determine if it's a function or not. If you're not sure, at least do the first part. So the next page, try this one. Okay, so start by writing the ordered pairs. So here's our ordered pairs. Very good. So 2 and 5, 1 and 2, 0, 1, negative 1, 2, negative 2, 5. The domain and range. What would be the domain and range? So first.
Domain is 2, 1, 0, negative 1,
Okay. 2, 1, 0, negative 1, negative 2. Usually we write it in numerical order. You don't have to, so if you didn't, it's okay. But it's always best if it is numerical order. So range 1, 2, 5, or 5, 2, 1 would be fine. Now, here's the big question. Ben, is this a function?
Yes. Yes. Yes, it is.
Okay, let's talk about mapping diagrams. Does each x have only one y? So let's start with 2. Does 2 only have one y value? Yes. Does 1 have only one y?
Yes.
Oh, yes. Does 0 have only one output?
Yes.
Does negative 1 have only one output?
No.
Yeah. Does negative 2 have only one output? So each input should have only one output. It doesn't matter if they share the same range value. We just can't have more than one domain value. Okay, so each input should have only one output. So in a mapping diagram, if you have a situation like this, 1x having 3 different outputs, that is not a function. Okay? However, if 3 different x's have the same y, as long as each x has only one output, that is a function. Remember, the definition of a function is each x has only one y. Each x. The different x's could share the same y value. It's just that each x has only one y. Each x, only one output. So only one arrow coming out of each x. If you have more than one arrow coming out of a number, it's not a function. That output has two or more. That input has 2 or more outputs. So the answer is yes, it's a function because each x has its own y. Each x has only one y. Only one y value associated with it. So 2 only has one number associated with it. 1 has only one number associated with it. Okay, we're talking about, doesn't matter if there's a repeat in the ranges, you just can't have a repeat in our domain. Is that making sense? Ish? Okay, let's move to the next page. So the first 4 are functions. The last 4 are not functions. So we're going to break it up into 2 different parts. We're going to look first at the tables and the charts. So notice the tables and the charts here. So we have coordinates not tables and charts. I mean coordinates and ordered pairs and charts. Okay, so if we're dealing with ordered pairs or a chart. So let's look at these ordered pairs. 2, 3, 4, negative 1, 6, 3, and 8, negative 1. This is a function. Let's look at this one. 1 and 2, 2 and 4, 3 and 6, 4 and 8, 5 and 10. That is a function. Now if we go below, down here, these are not functions. So this ordered pair, 10, 10, 12, 10, 12, 14, 12, 16, is not a function. And 1, 2, 1, 4, 3, 6, 5, 8, 7, 10 is not a function. So how can we look at an ordered pair or a chart and know that it's a function or not? Simone? Yeah, just check if there's any repeat in the x. So this x value of 12 is a repeat in the x. It's not a function because that means that input of 12 has 3 different outputs. 12, when you put in 12, you get 10, You get 14 and you get 16. 3 different points for 12, x a value of 12. So there's a repeat in the x. Is there a repeat in the x here? Yeah, the value of 1 has 2 outputs. So it's not a function. If we look at the ones above, is there a repeat in my x's? 2, 4, 6, 8. Who do I appreciate? Me. No. Okay, is there a repeat in the x there? No. So that means if there's no repeat in the x value, what that means is that each x has its own y, has only one y value. And so it is a function. Is there a repeat in my x values here? No. So it is a function. So it's very simple. All you got to see is look at the x. So who cares about the y? All the x is different. Now let's look at the graph. And let's remember, let's go up for a second. Remember that a domain or a function is when that each x has only one y value associated with it. So look at this graph here. These two graphs are functions. The bottom two are not functions. Why are the bottom two not functions? Give me an example for the circle. McLean.
Because on the vertical lines, it will be like you'll have two in the same place.
So if we look at, say, x equals 3, x3 equals 3 has two different y values associated with it. X equals 3 has two y values. Here, do we have places where there's two y values for one x? Yeah. So 6 has two y values as well. So there's a very simple way that we can actually see if it's a function or not when it's a graph. So when we have graphs, there's something called the vertical line test. Okay, so vertical line test. Does it pass or fail the vertical line test? And so what the vertical line, I'm going to show you in a second. So notice on these ones, no matter what, every x has only one y value associated with it. In the bottom one, there's x values that have more than one y value. So what is the vertical line test? Well, it's actually on the next page. If you look over in the next page, a function is a relation in which each independent variable is associated with only one dependent variable. When relations are represented by a graph, we use a vertical line test to distinguish that they are functions. The vertical line test is when we can draw a vertical line at any point on the graph and it should only ever cross once. So here's my vertical line. Will it only cross one no matter where? If this line is actually our graph. Here's my graph. No matter what, is that red line only ever going to cross once? Yeah, so it's a function. How about here? Will it only ever cross once? The graph is this guy. That's the graph. Okay, so if I do a vertical line, will it ever cross more than once? No, it won't. It'll only cross ever once. How about the next guy? If this is my graph, if I draw a vertical line, will it ever cross more than once? No, it's only ever going to cross once. So it is a function. That's called the vertical line test. So on the bottom, these ones are non-functions. Because if I draw a vertical line, at any point, there's places where it's going to cross more than once. Does that make sense? No? So here, if I draw a vertical line through a circle, it crosses twice, so therefore it's not a function. So it's only ever allowed to cross once. This weird graph right here looks like that. So there's multiple places that if we drew a vertical line, it would only ever cross once. So if I draw a vertical line here, it crosses 3 times. There's places where it only crosses once, but if it ever at any point crosses more than once, it's not a function. It has to be true the whole time. Okay, so what I'd like you to do is try these questions. State whether it is or is not a function. If you get stuck on D, just leave it. We'll go through it together. And then why or why not it is or is not a function. Number 1, function or not a function?
No.
All we gotta do is look at the x's. Is there a repeat in the x? Nope, so it is a function. Each x has only one y. B, function or not a function? Nada. Not a function. Okay. Y. Y. The value of the x value of 1 has two y values. One has a value of 2 and 4. Okay, Tyson. You look so excited. Yeah, not a function. And why? Fails VLT. Vertical line test. It fails the vertical line test. If you draw a vertical line, it crosses more than once. Okay, grab your calculators. There's two ways to know that this guy is a function. One way is graphing him on your calculator. So this is the first step in learning how to use our graphing calculator. Okay. So let's do this very step by step. Yes. You're gonna need to get one. Yeah, there's one on my desk, I think. Okay. So, sorry guys. Okay, so you're gonna, first button you need to push is y equals. Can you trade me collateral? Y equals. Y equals. Y equals. The very top left button is your first button, okay? Now, if there's anything in there, you can just push clear and it will delete. Our next step, so we're at y equals, we're in the y equals screen, we type in our equation, 2x plus 10. We type in our equation, 2x plus 10. And then you push graph. Graph button's right here, and there it is. If there's an error, I will need to look at your calculator. So, does that pass the VLT?
Wait,
That's like the diagonal ones, and it goes up one.
Okay, so it is pixelated. It is pixelated. So this is actually a straight line, okay? This is a straight line here. It's not like going up, over, up, over. It's just because of the pixels. So don't be thrown off by the pixels. Yeah. So it is a function. It is a function. It passes the vertical line test. Okay, so put your calculators down, please. Calculators down. Calculators down. Ryan? On your desk. Put them down. Yeah? Okay, so we'll look at it later because there's multiple reasons why that could be. Okay, so function passes VLT. The other way we know, this again, VLT, passes VLT test, vertical line test. The other way we know is it's a y equals equation and it's degree 1. Okay, what's degree again? Has to do with the exponents, right? They're all power of 1. Right, so degree 1. And so all degree 1 equations are lines. And all lines are functions, as long as they're not vertical. Not necessarily, so you can't, we'd have to rearrange the formula for y equals and try and graph it. So if you have like y squared equals 10, that's not a function, because it's a degree 2, y is degree 2. Y equals x squared, could you put that into your calculator? Yes, your calculator only graphs functions. If you cannot put it into your calculator, most likely it's not a function. Okay. Okay, last one is, or last two, is this a function? No, fails VLT. Okay, you two are added to that list. And last one, is that a function? Be very careful. Look at the x value of 1. Does it have two y values at 1? Yeah. See, if we drew a vertical line there, it crosses 2 dots. So at x equals 1, there's 2 dots right here and here. Right? At x equals 1. And so it's not. Pardon me? It failed VLT. Same as F. Yeah, you could just say fails VLT. All right, moving on to the next lesson.